Good day everyone, this video is prepared for Civil Engineering Lab 1 SEAA 2012 and we are from Group 20. The experiment for this video is G4-3 which is point load test. Our group member are LIEW, ATIKAH, Ting, GUAN and also me, VN. Introduction. Point load test is a test that aims to characterizing rock materials in terms of strength. It is an index test. The test can be carried out relatively quick and simple by using equipment that is easy to handle and protect. The test also does not require costly specimen preparation where samples can be core rock, specimen or irregular rock fragment. Hence, point load tests can be undertaken on site or in the laboratory. Several types of tests can be carried out depending on the specimen geometry, namely diametral, axial, block test, and irregulars. During the test, uncorrected point load strength P over D times 2 is obtained by measuring the failure load P and the distance between platens. A correction is applied to account for the specimen size and shape, and point load strength index IS50 is calculated. The objective of this experiment is to determine the compressive strength of rock specimen from irregular lump test. Before the point load strength test became an established test for general purpose rock strength classification, it was used mainly to predict uniaxial compressive strength when it was first introduced. Since the test is as reliable and much quicker to measure when it is properly conducted, point load strength tests now often replace the uniaxial compressive strength in this role. As correlations with uniaxial compressive strength are only approximations, the IS50 should be used directly for rock classification. Uniaxial compressive strength is 20 to 25 times the point load test averagely. However, the radio can vary between 15 and 50 for tests on different rock types, especially for anisotropic rocks. Hence, error up to 100% are possible in using an arbitrary ratio value to predict compressive strength from point load strength. The apparatus are irregular granite rock, vernier calipers, point load tester, and the following components. The width of irregular rock specimen is measured by using vernier calipers. The top width W1 and bottom width W2 of the irregular rock are measured. The W average is calculated by using the following formula. Next, the rock specimen is placed horizontally between the upper platen and lower platen. The distance between the two platen contact points D is measured. Next, the distance between the contact point and the nearest free end L is measured. The distance L is at least 0.5 times D. Next, the load is applied on the rock specimen. The load P, where failure occurs within 10 to 60 seconds, is recorded. Cross-sectional area of the rock is calculated with the formula A equals to W times D. The equivalent core diameter, DE2, of the rock specimens is calculated. Next, the size correction factor, F, uncorrected point load strength, IS, and point load strength, IS50 of the rock specimens are determined by using the formula shown in Table 2. Last, Step 1 to Step 8 were repeated by using another two rock specimen.
First, we measured the upper width and also the lower width of this rock specimen with this vernier caliper, which is perpendicular to the loading direction, and call it as W1 and W2. So that we can use this information to calculate the average width by adding W1 and W2 and then divided by 2. The rock specimen is placed horizontally between the upper platen and also the lower platen. The distance between the two platen contact point D is measured. After that, we steadily increase the load until failure occurs and record it as failure load PE. Lastly, repeat the whole experiment for different rock specimens. Thank you.
That's all from Group 20. Thank you.